The ideal waffle is defined by its geometry, a crisp exterior surrounding a light, airy center. Achieving this balance requires more than a standard box mix, which often produces a dense, underwhelming result. Early versions of this dish were simple, unleavened wafers. In medieval Europe, cooks poured a basic flour and water batter between two flat iron plates, often engraved with religious symbols, and held them directly over an open fire. Over time, the hardware advanced to cook thicker batters more efficiently. Craftsmen carved a distinctive grid pattern into the iron to maximize surface area, allowing heat to penetrate the batter rapidly and creating the pockets used for toppings today. Despite having precise electric waffle makers in modern kitchens, home cooks still struggle with rubbery or soggy results that collapse under the weight of syrup. To solve this, we have to look past basic instructions. We need to isolate the chemical reactions inside the batter and control the thermal temperatures of the iron with total precision. Applying the specific principles of physics and chemistry creates the conditions necessary for a crisp, airy interior. Step 1 is assembling the dry matrix. You need a specific ratio of all-purpose flour, sugar, baking powder, baking soda, and salt. All-purpose flour provides the necessary gluten proteins to hold the waffle together. It acts as the structural foundation, ensuring the batter has enough strength to expand without tearing apart. However, wheat flour has a structural weakness. As soon as you add wet toppings, the exterior absorbs that moisture and loses its crunch. To build a better moisture barrier, remove a quarter cup of wheat flour and replace it with cornstarch. This diagram compares wheat flour with cornstarch. Cornstarch's rigid amylose chains crystallize when heated, providing a stiff structure wheat flour lacks. Because it excels at absorbing liquid without gluten, these chains repel excess moisture from steam during cooking. Engineering the batter with cornstarch creates a firm, protective crust, protecting the waffle from becoming soggy once it hits the plate. Step 2 is the wet emulsion. Whisk together whole milk, eggs, vanilla extract, and melted butter. The butter adds flavor, while the fat coats the proteins in the flour. This lubrication ensures the finished waffle releases cleanly from the hot iron. The chemistry of the waffle changes the moment the wet and dry ingredients meet. When water meets wheat flour, glutenin and gliadin link to form gluten. Agitating the batter stretches these proteins into tough, elastic chains. If you whisk until the mixture is completely smooth, the resulting waffle will be tough and chewy. A successful batter should look thick and distinctly lumpy. Those lumps are simply dry pockets of flour. They will naturally absorb the surrounding moisture and disappear during the resting phase. Mixing only until the dry streaks disappear is the only way to ensure the interior remains tender. Step 3 is the incubation period. Leave the bowl on the counter for 10 to 15 minutes. This rest allows the starches to fully hydrate and the baking powder to react with the liquids, filling the batter with tiny air bubbles. While the batter rests, turn your waffle iron to its highest heat setting and preheat a kitchen oven to 200 degrees Fahrenheit. When the room temperature batter hits the hot iron, it triggers a rapid thermal expansion. At 284 degrees Fahrenheit, amino acids and sugars collide. This Maillard reaction forms flavor compounds and a golden crust. Simultaneously, liquid boils into steam, creating pressure that forces the batter to fill every pocket of the iron. Monitor the steam rather than the machine's indicator light. When the aggressive sizzling slows and dissipates, most of the internal moisture has evaporated. Opening the lid too early will rip the fragile waffle apart before the starch structure has set. Managing these thermal reactions transforms the liquid batter into a solid, symmetrical grid. Open the iron and carefully remove the waffle. This combination of a light interior and firm crust is what made the Belgian waffle an international success when it was introduced to the American public at the 1964 World's Fair in New York. There is one final failure point. Stacking hot waffles on a cold plate traps residual steam between them, softening the exterior. Step 4 is preservation. Transfer the cooked waffle immediately to a wire cooling rack inside your 200-degree oven. The wire rack allows warm, dry air to circulate fully. This maintains the rigid starch structure while you finish the rest of the batch. When you cut into the stack, the sharp crunch of the crust should give way to a light, fluffy center. Integrating these chemical and thermal principles results in a level of quality and consistency that standard recipes can